Welcome to another exciting exploration. Today, we're not venturing out into the vast expanse of space. Instead, we're taking a journey into the most complex object in the known universe, the human brain. That's right, folks, forget black holes and supernovas for a moment. We're talking about the 3 pounds of matter sitting right between your ears. This is the command center of your entire being, a biological supercomputer that puts even the most advanced AI to shame. We're talking about the organ that allows you to think, feel, dream, and experience the world around you. And trust me, there's a lot more going on up there than you might realize. So get ready to stretch your neurons and prepare to be amazed by the wonders of your own mind. The human brain is remarkable, with billions of neurons firing away. There are about 25 billion neocortical neurons in the human brain. They make about 140 trillion connections, synapses, between them. Let's zoom in on synapses, those tiny gaps where the real magic happens. Imagine two neurons separated by a minuscule space called the synaptic cleft. This gap is where crucial information transfer takes place. Neurotransmitters act like ships, carrying vital cargo from one neuron to another. A signal triggers the release of neurotransmitters into the synaptic cleft. These messengers bind to receptors on the receiving neuron. This binding triggers events, potentially generating a new signal. Information is relayed across trillions of synapses, forming the basis of brain function. Now here's where things get really interesting. The strength and efficiency of these synaptic connections aren't set in stone. They're constantly changing, adapting, and rewiring themselves. This process, known as synaptic plasticity, is the foundation of learning and memory. Every time you learn something new, you're strengthening connections between some neurons. It's like paving a new road in your neural network. Conversely, unused connections weaken over time. This highlights the dynamic nature of your brain, and it is called Hebbian learning. It's constantly adapting to your environment and experiences. So, we've talked about neurons and synapses, the intricate networks that make up the brain. But have you ever stopped to consider the physical weight of all that processing power? The adult human brain tips the scales at a surprisingly hefty 1.3 to 1.4 kilograms. Despite its small size, it's responsible for everything we do, think, and feel. Imagine packing all the computational power of a supercomputer into something the size of a small melon. Now, you might be wondering if the size or weight of the brain has any correlation with intelligence. It's a question that has intrigued scientists and philosophers for centuries, and the answer, like many things in science, is a bit more nuanced than a simple yes or no. While there is some correlation between brain size and cognitive abilities, it's not a direct relationship. In other words, having a slightly larger brain doesn't automatically make you a genius. Intelligence is influenced by a complex interplay of factors, including genetics, environment, and life experiences. What's more important than the actual weight of the brain is its structure and organization. The intricate connections between neurons, the efficiency of neural pathways, the different regions, and their specialized functions, these are the factors that truly contribute to cognitive abilities. Think of it like this. You can have a large computer with a powerful processor, but if the software is poorly designed or the operating system is inefficient, it won't perform at its full potential. Similarly, a brain with a complex and well-organized structure is going to outperform a larger brain that's less efficiently wired. The human brain is remarkably dense and complex. Let's start with the cerebrum. The cerebrum is the largest part, sitting atop the brainstem. It accounts for 85% of the brain's total mass. The wrinkly surface is the cerebral cortex, responsible for higher-level functions. The cerebrum is divided into two hemispheres, each controlling the opposite side of the body. The cerebrum is the control center of our thoughts, emotions, and actions. It processes sensory information and sends instructions to our muscles. It's the seat of our higher cognitive functions. We learn, remember, solve problems, and make decisions here. Different regions work together in intricate harmony. Next time you marvel at a sunset or solve a puzzle, thank your cerebrum. The brain's most abundant component is water. It's about 75%. Three-quarters of this organ is essentially water. It is crucial for brain function. It dissolves nutrients and transports them to brain cells. It also cushions the brain from impact. Water is essential for transmitting electrical signals. Given the brain's high water content, even mild dehydration can impact cognitive performance. Studies show dehydration impairs attention, memory, and reaction time. Symptoms include fatigue, headache, and difficulty concentrating. Dehydration also increases anxiety and irritability. So reach for water instead of sugary snacks. Stay hydrated to maintain optimal brain function. We often think of our muscles as the energy hogs of the body, especially after a grueling workout. But it's the brain that's the real energy guzzler when it comes to oxygen consumption. Your brain, this 3-pound organ that is responsible for every thought, sensation and action. It consumes 20% of the oxygen you breathe, 10 times its fair share. So the next time you take a deep breath, remember you're powering your brain. Now, you might be wondering why the brain needs so much oxygen. Well, oxygen is crucial for cellular respiration, the process by which our cells convert glucose into usable energy, known as ATP. And brain cells, particularly neurons, are voracious consumers of ATP. They need this energy to maintain their electrical charge, fire off signals and communicate with each other. Without a steady supply of oxygen, this intricate electrochemical dance would grind to a halt. Imagine a city's power grid going dark. That's essentially what happens to your brain when it's deprived of oxygen. Cognitive functions like thinking, memory, and sensory perception all depend on this constant flow of energy. This is why activities that increase oxygen intake, such as exercise and deep breathing, are thought to have beneficial effects on brain health. By ensuring an adequate supply of oxygen to the brain, we're essentially providing it with the fuel it needs to function at its best. So, take a moment to appreciate the vital role that oxygen plays in keeping your mental engine running. It's a silent partner in every thought, every dream, and every memory you've ever had. We live in a world obsessed with speed. We marvel at the velocity of cheetahs, the acceleration of sports cars, and the speed of the internet. But what about the speed of thought? How fast do signals travel inside our heads? Nerve impulses can travel up to 268 miles per hour. That's faster than a Formula One race car. This speed is essential for our survival. It allows us to react quickly and process information efficiently. Now you might be wondering how these nerve impulses achieve such breakneck speeds. The answer lies in the structure of our neurons, specifically in a fatty substance called myelin that wraps around the axons of nerve cells. Think of myelin as the insulation on an electrical wire, preventing signal loss and increasing the speed of transmission. Just like insulation prevents electricity from leaking out of a wire, myelin prevents the electrical signal from dissipating as it travels down the axon. This allows the signal to jump from one gap in the myelin sheath, called a node of Ranvier, to another, vastly increasing the speed of transmission. This process, known as saltatory conduction, is a marvel of biological engineering. It's like having a high-speed rail system inside your brain, allowing information to zip around with incredible efficiency. So the next time you're impressed by a display of speed in the outside world, take a moment to appreciate the even more impressive feats of speed happening constantly within the confines of your own skull. Your brain, with its billions of interconnected neurons firing signals at lightning-fast speeds, is a true marvel of nature. Can it be even faster? Yes. We have so-called electrochemical synapses, but there are species, like flies for example, who have purely electrical synapses. Those are much faster. And that is why flies can react with such an amazing speed. Memory, the ability to store and retrieve information, is one of the most fascinating aspects of the human experience. It's the foundation of our identities, shaping our perceptions and influencing our actions. Memories are widely distributed across networks of neurons interconnected by synapses. This process, known as synaptic plasticity, is the foundation of memory formation. Memory is not just recording and retrieving information, it's an active process, shaped by experiences, emotions, and beliefs. Recalling a memory reconstructs it from fragments. This is why memories can be unreliable. Memories change and distort over time. Each recall rewrites the memory, adding new details. You're not just revisiting the past, you're reshaping it. Now, let's venture into the enigmatic realm of dreams. Every night, as we drift into slumber, our brains put on a show, a bizarre, often illogical, yet utterly captivating performance. You see, dreams are a testament to the boundless creativity of the human mind. They're like abstract art, open to interpretation, filled with symbolism, and often leaving us with more questions than answers. But that's part of their allure, isn't it? Some researchers believe dreams are the brain's way of processing emotions, consolidating memories, and even rehearsing for potential future scenarios. Imagine that, your brain, a cosmic director, orchestrating a nightly play using fragments of your experiences, fears, and aspirations. It's like having a built-in virtual reality theatre inside your head, generating personalized narratives every single night. And the best part? Admission is free, though the ticket stub is often lost upon waking. Now, you might be thinking, I rarely remember my dreams. Does that mean I don't dream? We all dream every single night. Most dreams evaporate from our memory like morning mist. The most vivid dreams occur during REM sleep. Our brain activity ramps up, resembling wakefulness, but our muscles are paralyzed. Imagine acting out your dreams. Not exactly conducive to a peaceful night's rest, right? So remember, you were exploring your subconscious, a nightly spectacle fascinating scientists and dream interpreters alike. From the cosmic expanse of dreams, we journey now to a universal language that transcends cultures and connects us all: laughter. It's a sound that's music to our ears, a social lubricant, and, dare I say, a vital ingredient in the recipe for a good life. But laughter is more than just a fleeting moment of amusement. It's a complex physiological response, a symphony of neural activity that sets our brains ablaze. When we laugh, multiple regions of our brain light up like a Christmas tree. The auditory cortex processing the sound, the language centers deciphering the humor, and the emotional centers showering us with a wave of feel-good chemicals. Think about it. A well-timed joke or a humorous observation can instantly lift our spirits, dissolve tension, and even strengthen social bonds. It's like a mental massage, a neurological reset button that reminds us to not take ourselves too seriously. And the best part is that laughter is contagious. Like a cosmic ripple effect, one person's chuckle can trigger a chain reaction of mirth, spreading joy and positivity far and wide. Now, you might be wondering, is laughter really the best medicine, as the old adage goes? Well, while it might not cure the common cold or mend a broken bone, there's no denying the profound impact laughter can have on our physical and mental well-being. Studies have shown that laughter can boost our immune system, lower stress hormones, and even provide temporary pain relief. It's like a natural mood enhancer, a dose of feel-good chemicals that can brighten even the gloomiest of days. And let's not forget the social benefits of laughter. It brings people together, strengthens relationships, and fosters a sense of connection. It's a universal language that transcends cultural barriers, reminding us of our shared humanity. So the next time you feel a chuckle bubbling up inside you, don't hold back. Let it out, share it with the world, and experience the transformative power of laughter firsthand. From the vast networks of neurons to the enigmatic realm of dreams and the infectious power of laughter, we've journeyed through the awe-inspiring landscape of the human brain. It's a universe within itself, responsible for the boundless potential that resides within each and every one of us. But our exploration should not end here. There's still so much more to discover, to unravel, and to marvel at. The human brain, with all its complexities and mysteries, continues to captivate scientists and dreamers alike. So, keep that sense of wonder alive, my friends. Never stop questioning, never stop exploring, and always remember, the most incredible journey you'll ever take is the one inside your own mind.